Alright students, today our learning objective is to understand and use the proportionality theorems. First we have the triangle proportionality theorem, and then we'll have its converse, which is backwards. Reading here, you'll see that if a line is parallel to one side of a triangle, so you need to add the parallel mark here. If indeed these are parallel, ST parallel to QR, then it separates the sides into proportional lengths. I'm going to use color to demonstrate what I'm talking about. If the yellow side over the green side, if we put yellow over green, then it's going to equal blue over red. Okay, so how we write that is then side SP, this length SP, over this length SQ, it's going to equal PT over TR. Okay, I'm going to color code these so you can see where it came from. PT is blue, TR is red, SQ was green, and SP was yellow. So you can see where we got the sides. So if we put yellow over green, then it's going to equal blue over red. And that's what it means to be proportional sides. Okay, so here the converse is going to be, if we have proportional sides, then we know that this side is going to be parallel to this side. The base of the small triangle is going to be parallel to the base of the bigger triangle. So here, if a line intersects two sides of a triangle into proportional lengths, if this right here, this line intersects two sides, it intersects this side and it intersects this side in such a way that I have proportional lengths, I have this proportion, then I know that ST is going to be parallel to QR. So it's backwards. So let's go ahead and use the exact same color scheme. This is going to be yellow and green. So if I put yellow over green, then that's going to equal blue over red. Alright, now how is this going to look in your homework? Here is an example. Sometimes they're going to provide a picture for you, and sometimes you're going to have to draw the picture. So here I have side AE equaling a number, CE equaling X, DA equaling 6, and BA equaling 12. So I have a triangle ABC, and I have these other letters D and E. So I'm going to draw a triangle ABC tumped on its side just because of room, because sometimes they're not drawn like this that are sitting up straight. Sometimes they're tumped over on their side like this. So here I've got triangle A, B, C. And then I have this line here that's intersecting two sides. Call it D and E. And I had to label these so that I could create an AE and a CE, a DA, and a BA. Alright. That's E. Okay, so here I'm going to use the same color scheme again. This is going to be yellow and green, and this is going to be blue and red. Okay, and I want to find x so that ED is parallel to CB. So I am using the converse. I'm trying to prove that these are parallel. Okay, so I'm going to label what I have. AE is 8. CE is x. DA is 6. So DA I know is 6. And BA is 12. So this whole thing, BA, is 12. Well, you know that yellow plus green makes this entire side. And if you know the entire side is 12, then what must you add to 6 in order to get 12? That would be 6. So you know that this guy right here, we find it by saying 12 minus 6, which equals 6. Okay, now we're ready to set up our proportion. We set it just like this. Notice how I use the same color scheme, so you're going to use the same color scheme up here. You're going to put yellow, which is 6, over green, which is also 6, equals blue, which is 8, over red, which is x. And now it's just algebra. You cross multiply. So here I get 6x equals 6 times 8, which is 48. Divide both sides by 6, so you get x must equal 8. So when x equals 8, and only when x equals 8, then we know that ED is parallel to CB. All right, here's the next theorem. The next theorem is the midpoint similarity theorem. A mid-segment is the midpoint of two sides of a triangle. So remember, this is going to be the midpoint. So we know that KR and RJ are congruent because this is a midpoint. And we know this is a midpoint, so we know that KS and SL are congruent as well. Then a segment that is parallel to the third side of a triangle. Remember, mid-segments are parallel, so RS is going to be parallel to JL. And then we also know that RS is going to be half of this third side. So I'm going to move this up just a little bit. Remember that here we know that this segment is going to be congruent to 1, 2, 3. So I'm going to call this, I'm going to label this point M for midpoint. And I'm going to put 3 hash marks here to say that JM is the same length as RS, and ML, 1, 2, 3, is going to be the same length as RS. So all of these segments are the same. Okay, so that was from prior knowledge. That's all we know about the mid-segment. Okay, so if a segment that is all of these things, then we know if R is the midpoint of JK and S is the midpoint of KL, then we know that RS is parallel to JL. Note that you have to use with a parallel symbol. I know that some of you are still struggling with that concept, but when you use parallel or perpendicular, you must use segment notation. Must use segment notation. And then over here, we know that, remember, it's going to be, the length is half of the third side, so RS is going to equal 1/2 of JL. Okay, and here, because of the equal sign, excuse me, we do not use segment notation. Do not use segment notation. With the equal sign. Okay, so this is just continuing our information on midsegments. So it's called the midpoint similarity theorem. Okay, now for page 2. Alright, so on page 2, we're going to start up here with another theorem. And on this theorem, it says that if 3 or more parallel lines, 3 or more, I have 3 exactly, intersect two transversals, transversal 1, transversal 2, then they cut the transversals proportionally. So you can envision these as little bitty triangles. So you've got the small triangle, the medium triangle, and the large triangle. Okay, and remember, for the triangles to be similar, all you have to have are two angles that are congruent. You already have one here because all the small, the medium, and the large triangle, they all share this angle up here. And then remember, if these are parallel, which is what they're saying, if these are all parallel, parallels cut by transversals, you know that these angles right here are congruent because of corresponding angles. So now we know that all of these triangles, all 3 of the overlapping triangles, are similar, therefore the sides are proportional. Okay, so what I'm going to do is, again, color code the sides for you. This is going to be yellow and green, and this is going to be red and blue. Okay, so here, this is going to be AC over BD is going to equal CE over DF. And color code your side so you can see it. This is going to be yellow. This one's going to be green. This one's going to be red. And this is going to be blue. And see how it matches this exactly. This one over this one equals that one over that one. And then if you have information about these angles, you're able to set up this proportion and find the missing information. Alright, the next one. Okay, if 3 or more parallel lines, so here we start with parallel lines. Again, here, 3 or more parallel lines are cut by congruent segments on one transversal. So they're saying that these are congruent. AC is congruent to CB, so congruent segments on a transversal. So in other words, this transversal is going through all 3 lines at a way that makes these equal distance apart. Okay, so if that happens, then we know that the other sides are going to be congruent. So we're going to know that BD is going to be congruent to DF. Okay. So here, if they're equal distance, then they cut congruent segments on every transversal. Okay, so let's color code this. I have red. AC is red. And blue. This one's blue. Then I know that yellow, BD is yellow, and this one is green. Okay, so I know if these are parallel, and then this is a transversal so that these are congruent, then I know that these over here must be congruent. Okay, here's an example. Given AB, CD, and EF are all parallel, find CE. Find this length right here. Okay, well, here we're told that these two are equal, so therefore these must be equal. So therefore, CE must equal 9. And that's how easy that is. That's what it looks like in real life. Okay, next. The next theorem is for theorem for angle bisector. If a ray bisects an angle, then it divides opposite sides into proportional lengths. That's proportional lengths. Okay, so, alright, so here, if angle ACD, so I'm going to color this in green, ACD, this angle right here, that's what we're talking about, this guy right here, ACD, is congruent to this angle right here, DCB, DCB, this one here. Then what we know is that these sides are proportional. So these sides and these sides are proportional. So here, I'm going to color code these red and blue. So here, A is red, AD, that's this one, over DB, which is this one. Then it's going to equal CA, which I'm going to have in green, since it's on the green side of the angle. So I'm talking about this side right here, green, which is CA, over this yellow side right here, which is CB. I'm talking about this side. This one is CB. Okay. Here's an example. In triangle ABC, D is the midpoint of AB. So that's the first thing we have to do. We have to, you can fold this and find the midpoint. Just fold the corner to the corner and just press on it so you know that that's the midpoint right there. And label it D. Then E is the midpoint of BC. So up here I'm going to fold again and kind of match point C to point B. Put a fold. And we're going to call that point E. And F is the midpoint of AC. So down here we're going to do that again. So I'm going to fold and find my midpoint. It's right there. And you can hold it up to the light because that makes it easier. Okay, so right there, this is going to be F. And then it says, find the perimeter of triangle DEF. So I need to actually draw in triangle DEF. It's better if you have your straight edge available and just draw your lines. So here, this one, and this one. Okay, now you all should know that what we have just drawn are the mid-segments. So that mid-segment theorem, the proportionality of the midpoint, that is what we're going to be using here. So here it says find the perimeter of DEF if AB, this whole thing, this whole side is going to be 24. This whole side over here is going to be 32. And then this whole side down here is going to be 26. Now, what do I know about DF? If this whole side is 26, then DF is going to equal this and this. If this is the midpoint, then I know that this is 13, this is 13, and this is 13. Okay, since this is a midpoint, we're going to cut these in half. So I know that this is going to be half of 32 is 16, so that's 16, and that's 16. And I know that these two are congruent, but it's also congruent to DF. So this one over here is 16 as well. And finally, half of 24 is 12, so that's going to be 12. That's going to be 12. 1, 2, 3, 1, 2, 3. And I know it's congruent to this one over here. 1, 2, 3, so that's 12. To find the perimeter of DEF, I have to add the 13, the 12, and the 16. 13 plus 12 plus 16. That's going to be 8, 9, 10, 11. That's going to be 41. So that's going to be 41. And they didn't give me a unit, so I just put units. And that is it for lesson 6.6.